Hello again. We are continuing our discussions of applying derivatives to real-world situations. Last time we talked about rates of change that had to do with time. This time we are talking about more general rates of change. So let's get started. As an example, the cost of producing a certain number of items in a factory is given by the function c of x equals 0.00013x cubed plus 0.002x squared plus 5x plus 2,200. And some of those costs might be the cost of labor, some of them might be the cost of raw materials, and then there might be some other fixed costs associated with those. Okay, so we need to find the derivative of the c function, which will give us our marginal cost. Okay, so there is c prime. It is 0.0039x squared plus 0.004x plus 5. That is the derivative. Okay. So what I want to know is, what is the marginal cost when 150 items are produced? And we will interpret this. So simply replacing x with 150, I get that expression there. And if I evaluate that, I get 14.38. Now, what does that mean? It means that if I am producing 150 items, then the cost to produce more is going to be approximately $14.38 per additional item. Okay, so that's how I interpret the derivative. Now let's figure out how this compares to the actual difference. How much does it actually cost to go from producing 150 items to 151 items? All right, so the cost of producing 151 items, I go back to my original cost function and I plug in 151 items and I get a total cost of $3,448.19. And then the cost to produce 150 items, if I plug 150 into my original function, I get $3,433.75. That is a difference of $14.44. So remember, this is very, very close to what I got for the derivative at 150. It's actually only off by 6 cents. Remember, I got $14.38. So C prime is actually a good estimate of my marginal cost. So let's look at the graph and see why it is such a good estimate. So what I've done is I've zoomed in on the graph. Remember, it was cubic, but when I zoom in this much, letting my x only go from 149 to 152 items, and letting my cost go from 3,410 to 3,470, it looks very, very linear. So even though x is a discrete variable, remember, x can only be the number of items, and I can't have a fractional number of items that I'm producing. But if I did graph it continuously, I can use that to estimate the difference between the cost of any number of amounts and the cost of producing one more. Okay, so that is looking at general rates of change. If you have any questions, please let me know, and I will see you tomorrow.